Yes, in the previous class, in the paper chromotography, the last point we have studied, that is RF value. RF means the retention factor. And as you know, RF is equal to the distance traveled by the pure substance to the distance traveled by the pure solvent front. This is the ratio and it is given by the equation RF is equal to X upon Y. Then how to calculate the RF value? The RF value is nothing but a retention factor and it is defined as the moment of the distance relative to the solvent front in a given chromatographic system. Already the paper chromatography was studied. There is a stationary phase as well as the mobile phase, and both are in liquid state. They are immiscible with one another. And the principle as well as the technique behind the paper chromatography, that part is discussed in a previous class. Now we go for the calculation of RF value, and relative retention factor is defined as the moment of the substance relative to the solvent front in a given chromatographic system, and that is called as RF value. And here the RF value is depends on the first one is solvent that is used, the second one is a medium for separation, that is nothing but a quality of the filter paper, which quality of the chromatographic filter paper that is used. Third one is the nature of the mixture, means the mixture which contains the components. Those components are separated from one another by this technique. And here the nature of the mixture. Fourth factor is the temperature. And the fifth one is the size of the vessel in which the process is carried. Means the process is carried out in a glass vessel and its size is also important here. Then RF value is calculated in the distribution coefficient Kd of the substance or system is known. Here already I have told Kd. Kd is the distribution coefficient of the system is known as, that is RF, that is Kd, and this Kd if is known, and the area of cross sectional of two phases, and RF is equal to Am divided by Am plus As, where Am be the area of cross sectional for mobile phase, and as As be the cross sectional area of the stationary phase, and RF value identify the individual components and the intensity of the zone may be used as a measure of concentration. Now we go for the calculation of RF value by taking the sum of the examples. Here, say you can take the distance traveled by a pure substance in a mobile phase is taken as, that is 3.05 centimeter, and the distance traveled by a solvent front, it is taken as 5.33 centimeter. If the values are known to you, then you go for the RF equal to X upon Y, and RF equal to 3.05 divided by 5.33, and that gives the value of, that is 0.572 is the 572 is the RF value. Means if the distance traveled by the pure substance and the distance traveled by the solvent front, if they are known to you, then you go for the simple RF is equal to, it is a ratio, distance traveled by the pure substance divided by distance traveled by the solvent front, then you go for the calculation and it is found to be 0.572. And the problem is, here A and B has RF values. Both A and B has RF values in centimeter, that is 0.732 and 0.348. Here the solvent front moves 8.61 centimeter, and calculate the separated distance between A and B. This is, you go for the calculation. Here A and B are the two components and their values are given here, 0.732 and 0.348 centimeter. And if the solvent front moves 8.61 centimeter, then calculate the separated distance between A and B. You have to go for the calculation. Then we know 0.732, that is RF value, retention factor, that is equal to X upon the solvent front, that is moves, that is 8.61. From this you get the value here, 0.732 into 8.61, that gives the X values. Therefore X is equal to 6.30 centimeter. Similarly, this is for A, and for B, 0.348 is equal to Y upon, that is 8.61, or 0.348 into 8.61, that is equal to Y. Therefore we get the Y is equal to 3.00 centimeter. And if X and Y are known, then the distance between A and B, that is X minus Y, and X is 6.30 minus 3.0, we get the 3.30 centimeters is the distance between A and B, or X minus Y equal to 3.30. That is the distance. Like that, you go for the calculation of RF value as well as the distance between. Then you come to the last point of the paper chromatographic technique is, what are the applications of the paper chromatographic technique? Here, the separation of amino acids. Into bracket I have taken the proteins. You know, the complex amino acids, the condensation polymers of the amino acids are called as proteins. And here, the separation of amino acids, you can oleoproteins, peptides, can be done by paper chromatography technique. Here, if the protein contains different types of amino acids, they can be separated from one another, identified by paper chromatography. The second one is the several components of biological origin, such as carbohydrates are there, lipids are there, hormones, steroid hormones, nucleosides, alkaloids, all these can be studied by using the paper chromatographic technique. The third one is pesticides, halogenated insecticides and organophosphorus insecticides can be identified by using the paper chromatographic technique. At the same time, the inorganic metal salts, complex ions are also studied by using the paper chromatography technique. Fifth one is the structural analysis. You know, when the compound is isolated or a new compound is prepared, this structural analysis can be done by using the paper chromatographic technique. And last one is this technique is used to analyze the mixture of these sugars. You know, there are different types of sugars: dextrorotatory, levo rotatory, reciproc mixture. You know, and those can be analyzed by using the paper chromatographic technique. And this completes that is the study of paper chromatography and calculation of RF value and the applications. Next you go for the column chromatography for the next class. Okay, thank you for your patience hearing. I end up my talk here. Thank you.